All right, today we're jumping into something really fascinating from the world of cardiology. It's this new idea, a proposal, that could completely change how doctors handle acute heart failure. Think of it like an early warning system that could literally save lives. So let's get right into it.
Okay, so think about this. You're driving, right? You got green for go, red for stop, but it's that yellow light, that hey, slow down, something's about to change signal that's so critical. So what if? What if we had that same kind of clear warning sign for a heart that's heading into crisis? I mean, a signal before it's too late. For a long, long time, we just haven't had one, and that's the core of the problem we're going to unpack.
See, here's the thing. In medicine, there's this dangerous gray zone. A patient isn't exactly stable, but they're not in what we call full-blown, life-threatening cardiogenic shock yet either. They're on their way down, but it's easy for them to get underrecognized, maybe even undertreated during this super critical window. And believe me, this is where things can go south and go south fast.
So, let's start by digging into this gap in our current medical framework. It's something doctors have known about for a while now, and honestly, it has some really serious consequences.
The way things are set up right now, it's pretty much all or nothing. It's very binary. Over here, you've got stable heart failure, which is a well-defined condition. And way over on the other side, you have cardiogenic shock, a total catastrophe where the heart just can't pump enough blood. But what about that huge, massive space in the middle? That's the real danger zone. And here's the real kicker. This old system, it just completely fails to capture that gradual slide, from just being at risk to being in a full-blown crisis. We have these existing frameworks, like the SCAI stages, that's from a big cardiology society, and they have these early stages, A and B. But the problem is, they're so broad. They just kind of lump all these different patients together. This makes it almost impossible to figure out who is truly at higher risk and needs help, like right now.
Okay, so this brings us to the solution, or at least a proposed one. A big group of experts from all different areas got together and came up with a new concept, a new name for this gray zone, designed to make it something we can actually see and do something about.
And they're calling it cardiogenic preshock. Now look at this definition. What's so powerful here are the words transitional phase. It's not a final destination, it's a journey. It is that yellow light we were talking about. And that framing is everything, because it implies there's still time. There's a window of opportunity to step in and actually change where that patient is heading.
The goal here is actually pretty simple, but it's incredibly powerful. The idea is to create one standard definition so that any doctor in any hospital anywhere can spot these at-risk patients much, much sooner. It's that old idea, right? If you can name something, if you can define it, then you can actually identify it, you can monitor it, and you can treat it effectively.
So what does this actually look like in a real hospital? I mean, to make this idea of pre-shock useful, you can't just have an abstract definition. So the experts broke it down into two really clear warning signs. They call them phenotypes, that doctors and nurses can actually look for.
Okay, the first one is called isolated low cardiac index. Yeah, I know, it sounds super technical, but all you need to think of is this. It just means low pumping power. The heart's engine is sputtering, it's struggling, it's working way too hard, even if the patient's blood pressure looks totally fine. And that's what makes it so tricky. It's a really subtle clue, but it's absolutely critical.
The second warning sign is isolated hypotension. And I love this one because it shows just how nuanced this is. We're not talking about just a single low blood pressure number. The key here is a sustained drop from that person's own normal baseline. So a 10 or 15% drop for one person could be a massive red flag, even if their blood pressure reading is still technically inside the normal range for the general population. It's all relative.
So this really lays it out clearly. You've got two main scenarios. In one, the heart's engine is struggling. That's your low pumping power, even if the pressure seems okay. In the other, the pressure in the whole system is starting to drop from where it should be. They're two different pathways, but they both lead to the same dangerous destination. And the big deal is, now we have names for them.
And look, this is about way more than just adding a new definition to a medical textbook. This could be a genuine paradigm shift in how we even think about acute heart failure. The ripple effects could be felt across the entire healthcare system.
So why does this matter so much?
Well, it's a huge win on three different fronts. First, for patients, it means better care, getting recognized earlier and getting to the right specialists faster. Second, for research, it means we can design much smarter, more precise clinical trials. And third, for innovation, it finally gives drug and device makers a valid, concrete target to aim for. It basically takes this big, vague problem and turns it into a challenge we can actually solve. This quote from the experts who wrote the proposal really says it all. The potential to shift the paradigm from late-stage rescue to early-stage recognition and timely intervention. I mean, that's the whole ballgame right there. It's about stopping the fire before it becomes an inferno. It's about getting ahead of the crisis instead of just reacting to it.
All right, so what happens next? This is a really exciting idea, for sure. But you know how it is with science. This is just step one. There's a whole journey ahead.
And it's super important to be clear about this. Right now, this is a proposal. It's not a standard of care yet. The next crucial phase is all about scientific validation. We need the data, we need the studies to prove that acting on these pre-shock signs really does help patients, and, just as importantly, that it doesn't cause us to over-treat people.
And this is basically the roadmap for getting there. First, researchers have to figure out just how common this pre-shock state is. Then, they need to get even more specific about the different subtypes. A huge piece of the puzzle will be learning how to predict which patients are actually going to get worse. And from there, they can start testing specific, tailored treatments. It's a very methodical process, but it's how you turn a brilliant idea into a tool that doctors can reliably use to save lives. Which kind of leaves us with this big final question to think about. This whole concept, of formally defining the pre-crisis moment, could that be applied to other areas of medicine? Just imagine if we had a clear definition for pre-sepsis or pre-stroke. This idea of getting ahead of the game, of focusing on early recognition. That really might be the future of medicine right there.